and then we can do that. So I'm going to hit record. It's okay. Well, I tested it. Seemed okay. I don't know for sure. I used to. YouTube used to have this thing where you could just. Is that my computer? YouTube used to have this thing where you could just broadcast live for like an hour and record it. What's that? Yeah. Yeah, but they used to have it so that you could like show on your computer. Do they still? I mean, do they still do that? Oh, okay, maybe they put it into Twitch. I'll look into that.
LL Bean was the company that's now makes it, but it's like a live stream, but mostly used for video games.
Right. Well, this software that I'm actually using is called Game Capture.
Oh, okay.
I don't understand video games really well. I've played some. All right. So anyway, George Raver. The course is 417. This is a second level course in GIS. Yes. It is not showing up on your canvas. What's your name?
Go in and set every semester. I have to I don't know where it's at.
Okay. Okay. Great. Yeah, you're enrolled in the course. Yes. Got a question? Okay. All right. Yeah, I'm still learning the ins and outs of Canvas. The first year we adopted it was last year, so it's exciting. But got it now. All right. And so there's actually 4 sections of this course. So some of you are in. How many graduate students do we have? Okay. 1, 2, 3, 4. Actually, it looks like more than half of us are graduate students. We've got one on the coast. How many on the coast? Can't see everybody. Just one? Well, you are on the coast too.
Right.
Okay. So one sitting on the coast right now. All right. So over half of us are graduate students. That's great. Like I said, this is a second level. Now, for those of you that are graduate students, it may be that you didn't take a GIS course yet in your career. If GIS is new to you, that's fine. As a graduate student, I think you can catch up. And if you want to come talk to me or whatever, we can do that. There is a course, a 200 level course. It's the introductory to GIS course. So if you wanted to take that, you could, and we could. We've done it in the past. Sign people up as an independent study type project. You take the 200 level course, and then you do a special project. If it's a special project, you'll have to be me because the person teaching the 200 level course is a part-time adjunct. So you just do a special project. So those are your options. Some of you that are some of your graduate students look new, and I know some of you have emailed me. Anyway, if you'd like to take a true introductory level course, that's another option as well. Okay. I meant to get into that later. Let's go around and just tell me your name and what you're majoring in, and then anything else you want to tell me. That should be enough. We start with Michelle.
Well, as you just said, my name is Michelle, and I'm a dual major in GIS and geology.
Great. All right. So Michelle is enrolled in the course. So check that out.
Adam Terrell, normally I'm on the Gulf Coast. I'm a geography major and graduate student as well.
Doesn't really look like you in the picture. I don't think it's really small.
You got
Are you like next to a skeleton?
Yeah.
Okay. Thanks, Adam. All right. You're enrolled in the course.
I'm Avery, I'm in geology, and
Okay, great. Good to meet you, Avery. We worked in the booth this morning. They had a kickoff over there. Donuts. You good to go? All right.
I'm Forrest, and I'm in GIS.
All right.
My name is Cody Blogg, and my master's in economic development.
Okay. Yeah, I got that. This semester. Did you ask me about scheduling?
I had to get it approved in class.
Okay.
Maybe.
Yeah, there's something like that. Anyway, welcome.
Daniel Browning, graduate, GIS.
All right. Great.
Rosa Howard, graduate in biogeography.
Biogeography. Okay, great. So, is this your first semester? I haven't seen it around.
this is my first semester.
Good. All right, Tyler.
Tyler Ivy, GIS.
Okay. Jordan.
James Grisberry, GIS undergrad.
All right.
I'm Jennifer, I'm economic development.
Okay. Two economic development. That's great. Then on the coast, what do we got there? Any of you can go first?
All right, my name is Ian Stewart. Geography.
Okay, great. So is this your first semester of taking courses?
Yes, well, not like total, but like, yeah.
Right.
You're
Okay.
like,
As part of. All right.
and my name is Veronica, I'm a geography major.
Right. Yes. And you've taken courses before.
Yes.
All right. I got you. I'm here. Well, I think everybody is no. I think we're missing one student on the coast, but I think we've got everybody else. That's great. All right.
Who else signed up to take a course down here, Dr. Randall?
What's that?
Yeah.
Who else has signed up to take a course down here?
Christina.
Okay.
Yep, and she is signed up for the Gulf Coast section. So, like I said, there are four sections of this course. There's 2 graduate sections for both campuses and 2 undergraduate sections. But on Canvas, I've merged it all together. So that's why you see this thing that says, anyway, it says a lot of things like cross list, FA18. At least that's what it says for me. So all of the lecture and the lab are together. Okay? You have to be in both. I don't understand how all universities run. Some universities don't have separate lab sections and lecture sections, but we do here. And so I just combine them all so that you can go to one place on Canvas. I know my Canvas probably looks a little different than yours, but let's start off with the syllabus. Actually, if you go to modules the first week, download this PowerPoint. And then I think I'll talk about one of the syllabus first. Yep. All right, so all right, now you'll notice the first thing is that the university has kind of condensed the semester. They've shortened it by 1 week. We used to meet for 16 weeks. Now we meet for 15 weeks. And even when we met for 16 weeks, it could, because a 4-hour class meeting once a week had so many weird, like how many hours exactly does it meet, they all overbooked us. And they've actually done the same thing. Technically, we need to meet and talk and be in discussions where you're learning called contact hours for the equivalent of, even with the equivalent of 3.5 hours per meeting time. Okay, and so, sorry, a little bit over 3.5 hours. So what I like to do is meet for about 2 hours or so once a week. That's what we're going to do. So we're going to start at 11:30, just like it says in the syllabus, and we'll meet from 11:30 to 12:30, 1:30, and then we'll take a break for about a half hour. You either have to get an early lunch or really late lunch, I guess, on this day. Okay? What we're going to do. Then we're going to eat for another 2 hours. So that'll be about 4. Formal instruction will end, and we'll be for lab. Another hour of contact time. Because it's a lab, there's supposed to be unstructured contact time as well. Okay? And anybody is welcome to stay and ask questions and work along. But the formal part where I'm talking and we're doing stuff, we usually, in this class, end at about, what did I say, 4, right? So that's 2 hours, half hour break, 2 more hours.
Nowhere near 6:30 p.m.
Right. And that's why I'm hoping to, anybody else here, I know you're in the web mapping course, anybody that's here in the web mapping course? Yeah.
No, yes, Dr. Raylan.
What's that? You are?
I'm in the web mapping course.
There's only 2 people on the coast signed up for it, so anyway. So we've got almost half the people on that course right here. But I was hoping to move up to Wednesday just a little bit, so we get out a little bit early. Anyway, we'll talk about that in the web map. Okay, so my office hours for both courses are basically the mornings of Monday and Wednesday. I do have to occasionally set up a phone appointment. Lots of other work responsible for doing. Keep these times clear, not always possible. So I really appreciate it. Me and those times. Then it would work out. Plus, on the coast, you can't really drop it in. So please set something up if you're gonna come visit. Also, I like to help people through email and even Skype. We have this Skype for Business application now in the university, so I can get on Skype. You can share screens. I actually do this a lot for conference calls when I'm collaborating with other researchers. Say we look at each other's screen. It works great. So that's a possibility. Okay. All right. So we get into this in the syllabus, but basically this is a class where we're going to talk about GIS, specifically GIS problems that take the real world and conceptualize the real world as points and polygons. Okay? So most of the problems we're going to look to solve look at these entities or objects, how they're related to each other in space, rather than looking at a surface and how we model actual surface. I think it's really interesting. That's a different class. For 18 course, which does get taught on your basis as well. But we have to find some way to kind of distinguish these 2 courses from each other. And so we did that where we're talking about discrete shapes in coordinate space. Okay. All right, so to complete this course, you're taking a GIS course already. I already mentioned that, so actually I'm going to skip it. But one thing I do want to mention here is that in addition to any other course that you've had previously, we can sign you up for ESRI, the software vendor that we're going to use in this course. We can sign you up for some of their short courses. So if you feel like you're deficient, you want to like a basic intro to GIS course that's just you take it online, we can sign you up for that. And we're actually going to do one of those today. So today, as part of as the lab portion of the course, I'm going to turn you loose to work on those projects. So we'll discuss that later. But that way, when you see it and you do it, you say, oh, well, maybe it would be helpful to get an introductory course. Just let me know. And I can do that as well. most of the time on Canvas. That's probably an old line in my syllabus. They're always going to be on Canvas. I'm never going to give a hard copy out. It's hard to get hard copies through the IEN system anyway. So we, even with the shorter semester, we're going to stick with having one assignment a week. Just had to like reorganize. Maybe I shouldn't even. That's kind of deceptive. I haven't taught this course. Vandana Carr, who used to be a faculty member here, taught this course in the past. So this is the first time for me. There's a lot of new things about this course. So it's kind of exciting. I'll go ahead and talk about some of them now. So I went to the ESRI Users Conference this year. It's an annual gathering. It's in San Diego, where they talk about how great their software is. And so the ArcGIS software, there are two different desktop products now. And for a long time, we've been using ArcMap, a main software package, which is fine. ESRI says they're going to support that for another few years. However, in almost all of their examples, and almost everything that they did at the conference, they switched to this new package called ArcGIS Pro. And so we're going to, I'm going to say I've been using ArcGIS Pro for a while, but sometimes I get a little bit frustrated just with ArcGIS desktop. So this new application called ArcGIS Pro. So in this course, most of the time, I'm committing to, hopefully all the time, to use ArcGIS Pro as the software package. Now, I don't think it's installed on the coast yet, is it? I know it's installed up here, but it's an older version, so I'm going to work with some students this week, and we're going to install it. I'm coming down there on Tuesday. What's that?
Sorry, I didn't interrupt.
Is it on there?
I'm looking, all we've got is ArcMap 10.5.
Okay, great. So I'm going to work this week on getting the software installed on the coast and on all the computers here. I started here already, but I didn't get that far. So I started updating. We've got the older version here. Okay, so anyway, that's one of the new changes. And licensing ArcGIS Pro for these computers can be done in a few different ways. So I'm also going to make sure that we can license it correctly. One is the name user. I may just because it's not that big. So everybody just log in what we call ArcGIS online account. Who got it from our an hour ago? I sent those out. Some of you may already have our ESRI online accounts. If you do, that's great. You can just connect using that same account. If you don't, then just sign up. And what I'm gonna try to do is make sure all the lab computers you don't need to sign into. But I don't know for sure. This is a new product for me. I don't know for sure if I can do that. But on your own personal one, you'll need that ArcGIS. So if you want to install it at home, you'll need that ArcGIS account. For sure. You also need the ArcGIS account for the training. So you need to do it no matter what. So sign up using the link I provided. I sent it to everybody's USM email address that's on Canvas. Does that make sense? Not, if you have a different email address. I didn't send it there. So I just got on. ESRI, so maybe if you don't have it, check your spam. If you can't find it anywhere, contact me. Sign up. This is the software vendor for the GIS software we're going to be using. There are other options for GIS software, but they have such a large market share that a lot of the ideas and the data formats will be transferable to whatever GIS software package you guys ultimately at there aren't really any other big commercial companies, but there are a number of open source. So there's like a Linux of GIS too, which is really interesting, but we won't talk about it too much in this class. All right, so all the information is on Canvas. All right, so here's the course schedule. You can see and look over the cursory things here as to what we're going to talk about. But basically, we're going to spend the first few weeks diving deeper into overlay. You've probably learned about overlay and analysis, and we're going to really talk about what spatial joins are and how they can help us in analysis. Then we're going to look at proximity analysis. In a first GIS course, you probably talked about buffering, but we're going to look and see what kind of spatial analysis questions, what kind of questions can be answered through buffering, and then combine that with overlay. Then we spend a few weeks on spatial statistics. I don't see anybody here. There's a little bit of overlap here in the. We have a quantitative methods course for the graduates. It's really not much of an overlap. And finally, we're going to talk about network analysis. But sometimes people think, oh, that's like routing. I mean, just use Google Maps. Question for you. Use Google Maps from one place to another. Everybody has, right? Type of technology and the same kind of concepts that a GIS system uses to route you through a road, okay? But you can answer all sorts of more complex questions if you model the data correctly and you think about the way it matters. So you could you could look at a bunch of different points on the network and look at the connections between those points and use them to analyze something. For example, are the people that live here and here, in general, more connected than the people that live here and here? Well, to do that, you'd have to know all of the connections, and you have to be able to ask the GIS system the proper question. Roads aren't the only network out there either, especially that things flow on. There's things in biology. I helped a graduate student this summer that was working on a biological project that was actually looking at the connections along a river system. So in most cases, those connections only flow in one direction. In other words, the downstream items aren't connected to upstream, but upstreams are connected in various ways to things downstream. So any entity that can be modeled as a line or an edge in a network can be utilized to or can be put into a GIS system and then be analyzed to utilize the connectivity of that system. So it goes way beyond just finding routes, although that is a. So that's what we're going to talk about there, and then we're going to look at enterprise databases and databases themselves. This is actually where it's going to get a little bit outside of just ESRI. Databases themselves are starting to, well, I shouldn't say starting, but people are starting to utilize these tools that they have more abundantly, and the databases themselves can do some spatial analysis. So you don't need a special GIS software package. The database itself has the ability to say, okay, what other objects, what other things are nearby me? What other objects overlap or are contained or within my particular object? So that's what we're going to talk about. And finally, this is kind of a summary week that we'll get to at the end of the course. In terms of the grading, there's I can get really specific here. You'll have these weekly assignments, and then you'll also have a final project. The graduate students will have to write a paper about the final project. The undergraduate students will just basically write a couple paragraphs about the We'll discuss the project later, but it basically will be similar in effort to a lab, and you'll just be applying some of the principles that you learned. Okay, the rest of it is kind of boilerplate. You can go look at it whenever you want. Do you have any questions about that so far? All right. So this was all most of the syllabus here. So I really don't have any concept of exactly how long this is going to take to go through today, but I am pretty sure that it'll be less than usual. So we'll be out before, that would be 1:30. I think we might just go all the way through rather than having a break. So my goals are to go through this, to talk about the course in general, and then show you how to get set up in ArcGIS Pro, and show you how to do the how to connect to the online learning, so you can do the first lab, which is going to be an online learning lab. Okay, hold on just a second. We'll get to later in the spatial relationship that you're trying to discover in your data. In other words, if you're trying to make a relationship that you think exists over a mile or 2 miles or meters, then you need to make sure that your data set goes not just there, but actually twice there. Okay? If you think about it, if it doesn't go twice past that relationship that you're trying to discover, then, because your edges are always going to be skewed. And so the things that are right next to the edge are going to be a little bit skewed, and your data will get skewed further as you go out. I think technically 1.5 is an okay boundary there. So anyway, all right. So geographic relationships. That's what we're really going to talk about this course. And I started typing up all those, but I didn't quite get to it. I did my lectures backwards. This is web mapping one first, so that one has a little more slides. But I started talking about some of these. But we're going to be talking about, we're going to do some, well, I shouldn't say we're going to do some math. We're going to talk about things that are expressed mathematically in this course. It's not like a math course where I'm going to send you home and you're going to have 20 problems to work out to find the distances between things, right? But you're going to have to understand that distance is, particularly in the vector GIS world, is a mathematical formula. There's a way to calculate distance, and luckily the GIS is very good at that. And distance is going to be a key concept in establishing relationships between real-world entities and trying to discover if there is, in fact, a relationship. Okay? Distance. Adjacency. Adjacency, you might not think of the term adjacency as also being mathematical, but but it can be thought of as the nominal binary equivalent of distance. In other words, are things adjacent? You have to define what adjacency means at that point. Adjacency means that are they next to each other? Are they next to each other? What does are they next to each other mean? Does it have to do with distance? It can. Adjacent can be everything within a certain distance. So if we're interested in discovering a relationship that has to do with adjacency, we say, do adjacent things do X? Well, we know that we're going to have to like do a buffer or something in our GIS to start to answer that question. But that's what this course is going to be about, is first, what type of questions can we even answer? And what type of relationships can we discover? And then, how do we do that in GIS? What's the right tool to calculate adjacency? Because adjacency might mean, for our particular question, do they actually touch? Okay, we can do that in a GIS. How far away are they? Are they within a certain distance? Because we discovered that things within a certain distance are related and things beyond a certain distance aren't. So it's nominal binary. Do they touch? Yes or no? So polygons can be adjacent sometimes if they share an edge or a vertex. Points if they're in a distance. Lines if they intersect. Sometimes if they're in a distance of. So interaction is the third kind of relationship I want to talk about. This may be considered as a combination of distance and adjacency. So one way to think about this is, as I get further away, the strength of a relationship diminishes. Sometimes we refer to that as inverse distance weighting. In other words, if I'm going to say these two items are related, I might say that they have a high spatial weight. And the further they are away from each other, the lower weight they have. So as I get further away, there's less of a relationship between those objects. So this concept of distance, adjacency, and interaction, you'll notice, particularly when we start talking about the spatial statistics, that we're going to calculate things that are, I don't know if surrogates is the right word, we're going to calculate things that represent these concepts of adjacency, distance, or interaction. Sometimes, really, distance kind of builds on interaction. So we have to spend the first few weeks really explicitly talking about GIS data management and how to conceptualize these and calculate these concepts using various GIS tools. All right. I didn't mean to skip the neighborhood. Neighborhood is something that you hear about more often in raster GIS analysis, but neighborhood is just as valid of a concept in sometimes in different classes. The term neighborhood can be defined as a region. Usually we think of neighborhoods as like a smaller thing and regions as a larger thing. A neighborhood is the idea that regions in a spatial distribution are alike and neighborhoods distinct from other regions. All right. So some of these exercises are going to be are going to be focused on coming up with neighborhoods and defining neighborhoods and seeing what's the spatial similarity between different things in order to answer questions like. Is this an area that is unique or different than other areas? So we might use that in conservation to say, let's set this aside. We might use that same information to say this would be a good candidate to explore for some resource or explore for archaeology, or this might be a good candidate to place a new store. So we've got all sorts of different applications there. All right. So we went about an hour and a half today. Like I said, I do think that I want to just to just go right into it, so that way we can dismiss for today. Anybody object to that? Like, would you rather take a 20-minute break? Okay, 5. Yeah, that's great. Let's do 5-minute break today, And then I'm just going to take probably a half an hour to walk you through getting set up in ArcGIS. I'm going to stop the video right now. I'm going to call this something different first.
Will, if we email you for a new code, ArcGIS code, will that work for ArcPro as well? Might